Rung is an education platform that helps elementary and middle school teachers see where each student actually stands with the current curriculum and gives teachers a guided plan on how to help these students. So for the purpose of this demo, I will first start from the teacher's point of view. So from the teacher's point of view, we'll use a sample. Teachers will usually create a workspace, and in this workspace, students can join. And in this workspace, teachers will assign a diagnostic test to each student, and the heat map kind of shows how each student performed for each topic within the diagnostic. And based on how students performed for specific topics in the diagnostic, it will group these students into groups so that they can learn together. So for example here, as you can see, this is the suggested group our platform suggested. So there's 3 students. It'll give a mini lesson plan for the teacher for the next day to help with next day's lesson plan, as well as give them match practice sets and then a video for the students to practice on. Now from the student's point of view, when they join it, they have to join with their nickname, and then they start and take the diagnostic. And for here, I'm just going to answer however I want because it will give us a curated plan based on how I perform, which we'll see in a minute. But so now that I've completed the diagnostic, as soon as I've finished, I can see my results, and we'll see that the platform has actually built me a curated plan based on how I did. And at the bottom, I can see how I did on the diagnostic, and then these are the recommended topics that the platform has given me. So for example, if I'm stuck on this, let's say I'm taking this and I'm stuck on it. Say I don't know, and then I use it to answer it, and I'm stuck. Well, we have actually built in an AI feature to help these students. So as we can see on the bottom left, there are varying degrees of which the AI can help you. You can either get a nudge, so just a little help, a little push, a hint, and then also a guided step. And these are just various degrees of help. And this is the gist of our product. Well, now for how Codex actually helped us in this. Well, we use Codex to build our educational app in Next.js, and it really helped us take it from just an idea into a demo. And our core strategy while using Codex was to match the work to the model's strengths rather than prompting reactively. So our biggest win came from specifying targets precisely up front. We wrote architecture.md and contracts.md ourselves, then had Codex freeze the type contracts and fallback shapes before feature work began. And the lock contracts made Codex fast and accurate, while the vague ones erased the time savings in re-review. And this upfront spec also let us run parallel Codex sessions, for example, server logic, AI layer, student UI without conflicts. And Codex, the biggest one that we saw was Codex outperformed us on precision heavy code. For example, exact fraction arithmetic, migration, schema changes. These are all small errors that could surface silently later. And Codex also excelled at reading the whole code base. It traced misattribute bugs to its real cause, caught it leak in its own fix, and introduced and reconstructed a missing log entry from source. And it wrote tests immediately after each behavior, which we ended at 219 tests across 35 files. And we didn't accept a session's output until types, tests, and a production build passed. And that thoroughness really helped our team work too, because instead of reading code merges, we had Codex walk through what changed and how it tied to the contracts. And we also matched model variants to tasks. For example, Luna for high volume runtime calls, Terra for heavier drafts, and Sol for code review. And that was really how we used Codex and GPT 5.6 in building this project.